Seeking English, S.A.T. Workbook, page 376, problem 2, no calculator. It says, a system of linear equations is shown below. Which of the following describes the graph of this system of linear equations in standard XY coordinate plane? I'm always saying that in the time that it would take you to decide not to graph something, you'd probably be graphing it. This might be an exception. If you absolutely must graph this thing in order to see what I'm talking about, then do that. But this problem gives you a lot to notice before you get things on the graph. In the process of trying to graph it, you will probably notice, wait a minute, I'm already at my answer. Okay. These equations are deceptive because one has this 2y and one has this 1/2 y, but they're deceptively deceptive. What do I mean by that? I'll show you in a moment. The possible answers are A, 2 distinct intersecting lines with the same y-intercept. B, 2 parallel lines with a negative slope. C, 2 distinct perpendicular lines. D, a single line with a negative slope. So let's consider these one at a time, just with what's there, before we start doing anything else. 2 distinct intersecting lines with the same y-intercept. Plus 11 and minus 11, okay, they don't look like the same intercept point. Now, if one of these equations had been distorted in some way that produced a negative or a positive would otherwise be, then the 11 could match the 11, but this 2 and this 1/2 kind of mess it up also. So neither do I see the negative being flipped to a positive, which would be necessary, or positive to negative, in order to produce a single intercept. Nor do I see this 2 and this 1/2 producing the same result when they're corrected into the intercept point. So on those two bases, the intercept point is going to be different. So A is not possible. You don't really have to do anything else with it, unless you're just not convinced. Then yeah, well, I know we're going to get there, but you probably don't have to do anything else just to see that, if you know what to look for. B, 2 parallel lines with a negative slope. Parallel lines would have different intercept points, but they would have to have the same slope, and here it says negative slope. Let me save you some trouble there. This one has a negative slope when this y is positive. This one has a negative slope. This one has positive, so this is going to be a positive slope. Okay, so they can't be parallel if they don't both have either positive or negative slopes. They have to have an identical slope. Okay, so they're giving you a lot of ways to eliminate these 3 bad answers if you will just look at what's already there. And I might go a little further to take this a little bit further apart. But let's take a look. Letter C, 2 distinct perpendicular lines. This one's kind of funny, so I'm going to come back to it after letter D. D, a single line with a negative slope. Again, this one doesn't have a negative slope. And to be a single line, they would need both the same intercept, which they don't have. And they would both need exactly the same slope, which they don't have. And so even if you had two equations for the same line, and then one of them was just doubled and the other one cut in half, that would work. But again, compensating for this 2 and for this 1/2 doesn't produce identical equations. You might try it and won't do it. So by process of elimination, we have to come back to letter C. Now, there's a kind of bait and switch thing in here where, what's the joke? No, you only think that's counterintuitive. Is a kind of a joke. If you look at these slopes here, I know there's a 2 and there's a 1/2. But you look at these slopes here, 4/3 and -3/4. This fits the format for A over B converted to negative B over A. Okay, to get 2 perpendicular lines. So once you've spotted that, you may think that you're being trapped into believing that you're looking at perpendicular lines when you're not, because of this 2 and this 1/2. But that's a funny thing here. Watch carefully. I'm gonna forget about these since that's not part of the question at this point. Okay, this 2, if you compensate for this 2, it disappears into this denominator. Okay, if you compensate for this 1/2, it disappears into this numerator. So you get -3/8, okay? and you get, yeah, you get 8 over 3, which is again a over b and minus b over a. So they they made it look a little bit more complicated than it really was. So they're trying to get your intuition to work against you. And I don't know. Go ahead and graph it if you want to, but like I said, I think this one's an exception, and if you learn to spot exceptions, you'll spend less time graphing. But if you can't spot the exceptions, like I said, if you need to draw it, go ahead and draw it. Don't sit there deliberating about whether or not you should draw it.